Hi everyone, Mrs. Paglione here, going over our first video of week 1 of new material for distance learning. It's going to be about probability and odds. Okay, so what I'm going to do is I'm going to go through the notes with you. Hopefully you can pause the video at any time that you want, fill in the notes, then go back to play the video, whatever you feel most comfortable with. But the first beginning is a bunch of vocabulary, so I filled it in all at once for us right here. So if you want to, and actually what I suggest that you do is pause the video right now and fill out these vocabulary definitions. Okay, so once again, pause the video for me, please. Press pause, fill out these definitions, and then we'll come back to go over them in about 1 second. So please pause the video. Now that you've gotten a chance to fill in these definitions, I want to go over them real quick with you. So outcomes are all the possible things that could happen. We also consider that the sample space. So what can we pull from? If I'm rolling a die, that's going to be 6 numbers. So 1, 2, 3, 4, 5, and 6 would be my outcomes, and that list of numbers would be my sample space. Probability is the likelihood of something happening. So for example, if I look outside today, it's a beautiful sunny day. The probability or the likelihood of it raining is probably less than 5%. Or you could write it as a fraction, which is how we're going to describe it together. Favorable outcomes is what you want to occur. So I want it to be sunny, so that would be a favorable outcome. Where an unfavorable outcome would be what I don't want to happen. I don't want it to rain, so that's my unfavorable outcome. Odds is a little bit different. So odds we use kind of more in a gaming sort of atmosphere, so whether that be sporting events or other things, but basically what you're doing is you're comparing favorable to unfavorable events. So this is more of a ratio than it would actually be a percent or a likelihood of anything happening. Theoretical and experimental probability go hand in hand. Theoretical probability is what you expect to happen. So before you do anything, what do you think is going to happen? Where experimental probability is you actually go through the experiment, you actually collect data, and you find out an actual data number of probability, and then you can compare those two. We're going to end with theoretical and experimental at the end. All right, so going down here, probability. Probability is what we want to happen, want to occur over the total amount of things that can occur. All right, probability is a number from 0 to 1 or 0% to 100% if you write it as a percent, and it can be expressed as a fraction, which is how we're going to use it. It can be expressed as a percent, or it can be expressed as a decimal. Okay, and when we compare probabilities, what we try to do is we try to put it on this type of spectrum we have here, where we're kind of comparing it between 0, 1/2, and 1, or 0, 50%, and 100%. 0 would be impossible. It's never going to happen, no matter how many times it's going to happen. That would be like us, I don't know, maybe in the summertime and expecting it to snow. Having it be 100 degrees outside, it's never going to snow. So that would be impossible. 1 is certain. It's always going to happen, absolutely. And then 1/2 is equally likely. And then once you get going over to the left-hand side, you're getting more towards the unlikely. So 0 to 1/2 is unlikely. 1/2 to 1 is getting a little bit more likely. All right, here's our first example. A bag holds 8 pieces of paper numbered 1 through 8. Nick chooses a piece of paper at random. What is the probability that Nick will choose a 4? How likely is it? So likely means we want to use the words impossible, unlikely, equally likely, likely, or certain. So we're going back up to this sort of spectrum that we have up here. All right, so he has a bag with paper. Paper is numbered 1 through 8. So I'm going to create our sample space. So our sample space is the numbers 1 through 8. 6, 7, 8. That's our sample space. So our sample space are the outcomes. He can get the number 1, 2, 3, 4, 5, 6, 7, 8. He wants the probability of a 4. Well, how many 4s are there in our sample space. So remember, it's what we want to happen, and what we want to happen is the number 4, the piece of paper with the number 4, over the total. All right, well, there is only one 4 here. So there's only one piece of paper with a 4 in it. So that's going to be a 1 in the numerator. The total amount of things he could have is the total are going to be all of them. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total. So the probability is 1/8. So if I come up to my continuum here, 1/8 is going to most certainly be less than 1/2, which means it's putting it in the unlikely category. So it looks like this happening is going to be unlikely. You can also, if you have your calculators with you, you can figure out what 1 divided by 8 is as a decimal, and it's a 0.125. Well, 0.125 is definitely less than 0.5, which is 1/2. All right, let's look at our next example. So it says a number cube, which is like a number dice, with numbers 1 through 6 are rolled, or is rolled. What is the theoretical probability of rolling a 3? All right, let's write out our sample space. So our sample space is a 1, a 2, a 3, a 4, a 5, and a 6. We want to know the probability of rolling a 3. Well, that's what I want to happen over the total amount of things that can happen. Well, my total is that I have 1, 2, 3, 4, 5, 6 numbers. So 6 goes on the bottom. What I want to happen is rolling a 3. Well, I only have 1 3. It's right there. So since there's only 1 3, the numerator is 1 because there's one number that I want, which means my probability is 1 out of 6. So if I do 1 divided by 6, it gives me 0.1666 repeating. Well, that's less than 50%. So less than 50% means that it is unlikely to happen. Okay, unlikely. All right, what is the theoretical probability of rolling an even number? So we've got the same sample space, which I'm going to rewrite up here in pink. That's 1, 2, 3, 4, 5, and 6. We want to know what's the probability of rolling an even number. Well, that's what I want to happen over the total possible things I've got in my sample space. Well, I've got 6 total things in my sample space. That doesn't change. 1, 2, 3, 4, 5, 6. So there's 6 total. That's at the bottom. What I want to happen now is the even numbers. 2 is an even number, 4 is an even number, 6 is an even number. So there are 3 even numbers, the 2, the 4, and the 6. So there's 3 of those, 3 in my sample space. So that's 3 out of 6, which reduces to 1/2. Now 1/2 is a little bit different than what we've seen so far. 1/2 is exactly in the middle, exactly 50%. So if I come up here, 1/2 is labeled as equally likely. Okay, so I would write this down as how likely? Well, it's equally likely. You got a 50% chance of it happening. Odds in favor is a little bit different, okay? It's what you want to happen, but not out of the total, it's out of what you don't want to happen. And we end up usually writing it like a ratio with a colon in between, like 1 to 2. The total does not go on the bottom. We don't use the total at all for this, okay? The total is gone. It's what you want to happen over what you don't want to happen. Okay, that's odds in favor. Favor means the one goes on top. Odds against is the flip of that. That's what you don't want to happen because against is a negative word. So you're going to start with the negative. Well, what I don't want to happen goes on top. And then what I want to happen goes on the bottom. All right, so once again, you've got against is a negative word. So you're going to start with the negative, which is what you don't want up at the top. Okay, let's go over some examples. So suppose you randomly choose a letter A through J. All right, so I'm going to write my sample space. So bear with me. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And so as you can see, Cooper and I have been singing our ABCs. So only A to J. They want us to stop at J. So what are the odds in favor. So favor is a positive word, which means you're going to start with the positive, which is what you want, and then put what you don't want at the bottom. So what I want is odds in favor of choosing a vowel. Well, a vowel means that would be my A, E, I, O, and U. But O and U aren't in my sample space, so just A, E, and I. So what I want is 1, 2, 3 of the numbers. Here's the difference. What you don't want are the ones that I didn't circle. So I'm not including the A, the E, and the I. So what I don't want here is B, C, D. So 1, 2, 3, 4, 5, 6, 7. F, G, H, and J. So 1, 2, 3, 4, 5, 6, 7 of them. You can write it as a fraction, but most likely my answers are going to be as a ratio with a colon, just because I don't want us to think we can create a percent with this. We can't create a percent. We're just comparing what we want to happen, which is 3 numbers or letters, to what we don't want to happen, which is 7. All right, looking at the next one. So I'm going to go through and actually delete all my circles and underlines because I'm starting over. New problem, start over. Odds against. So since it says against, you start with the negative. So I don't want goes on top over what I want, which goes on the bottom. So odds against choosing a C. So what I want is the C. So there's only one C here. So what I want is a C. What I don't want is every single thing else. So that's the A, the B, the D, the E, the F, the G, the H, the I, the J. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would write that as 9 to 1. Not good odds. If it's odds against, that means most is against you. All right, last one, odds in favor for this. Odds in favor is what you want to happen, because favor is a positive thing, over what you don't want. So you want to start with the positive. So not a vowel, it's called a consonant. So what not a vowel would be all of my consonant ones. So that would be my B, C, D, F, G, H, J. So that is what I want are those non-vowels, those consonants, 1, 2, 3, 4, 5, 6, 7 of them, over what I don't want, which is 1, 2, 3 of them. So that's going to be 7 to 3. Okay, so as a little recap there, probability is what you want over the total. So you're going to use the total for probability at the bottom. Odds, you're going to use what you want and what you don't want. So you're not going to be using the total at all. All right, the last thing I want to go over is theoretical versus experimental probability. So theoretical is what should occur if you were not to do an experiment at all, if you were just going to basically everything that we've been doing with probability, because we have not picked any pieces of paper out of a hat, we haven't rolled any die, anything like that. Experimental is what actually happened when somebody did the experiment. So if we look here, it says a number cube with numbers 1 through 6 is tossed 30 times. The results were recorded in a table. So this right here, this is the experiment. Okay, so somebody did the experiment. What is the experimental probability of tossing a 3? How does this compare to the theoretical? So let's do the theoretical first. So the theoretical, I'm going to write my sample space is 1, 2, 3, 4, 5, 6. So the probability of tossing a 3 theoretically should be 1, because there's 1 3 out of 6 total numbers. Okay, so 1 out of 6 ends up being about a 17%. Now, experimental, I have to go through and actually count this. So I have to count however many 3s we have. So when I go through and I count that, I have about 6. Actually, I have a total of 6. You can see I circled them. That's 6 out of 30, which reduces to 1/5. And 1 divided by 5 is a 20% chance. So 20% is greater than 17%, so the experimental probability is greater than the theoretical one. All right, go ahead and try the homework and check the answer keys. I am here. Reach out to me if you have any questions, and I'll see you very soon.